Hi friends, today our topic is AC machines. Generally, AC machine nothing but synchronous machine. As per our syllabus, as per our examination syllabus, AC machine nothing but synchronous machine. But in generally, AC machines are two types. In generally, AC machines are two types. What are those? One is the synchronous machine and other one is the asynchronous machine. Synchronous machine and asynchronous machine. Synchronous machine nothing but, can you tell me what is synchronous machine? Can you tell me what is asynchronous machine? Asynchronous machine is also called induction machine. Asynchronous machine is also called induction machine. Now tell me, what is synchronous machine and what is asynchronous machine? Generally, in both the cases, we have a stator as well as rotor. We have a stator as well as rotor. Of course, for example, this is synchronous motor and this is asynchronous motor. For motor, we have to give the electrical supply, right? So, I am giving a three-phase AC supply to the stator. Three-phase AC supply. I am giving three-phase AC supply for both the machines. When three-phase AC supply given to the stator, it produces a magnetic field. We discussed in induction machines already. It produces a magnetic field which rotates in clockwise direction. The magnetic field produced in the stator, that magnetic field is rotating in particular direction. What is the direction? The direction is a clockwise direction with some speed. That speed is taken as synchronous speed. That speed is considered as synchronous speed. Someone asks you a question, what is synchronous speed? Can you tell me? People say constant speed or something. That is not exact definition for synchronous speed. What is the exact definition for synchronous speed? The speed of the stator rotating magnetic field. The speed of the magnetic field in the stator is called synchronous speed. This is the magnetic field speed which rotates in clockwise direction in AC machines. Now, see here, due to induction process, actually, this flux links with the stator conductors. This flux links with the stator conductors after some criteria. Here, rotor flux also produces. In this rotor, the flux produces. That flux also rotates in clockwise direction. With same speed, which is called synchronous speed. This is the stator magnetic field and this is the rotor magnetic field. If our rotor also rotates with the same speed of this magnetic field. For example, I am taking, this is my rotor speed NR and this is also my rotor speed NR. Here is the rotor speed NR and this is the rotor magnetic field speed NS and this is the stator magnetic field speed NS. Same rotor speed stator magnetic field speed and rotor magnetic field speed. For example, if my rotor speed exactly equals to synchronous speed, that machine is called synchronous machine. If my rotor speed exactly not equals to synchronous speed, if it is not equals to synchronous speed, that machine is called asynchronous machine, or simply it is called induction machine. In induction machine, the rotor speed never equals to synchronous speed. You know that concept. We discussed earlier in induction machines. So, in which the rotor speed exactly equals to synchronous speed, that machine is called synchronous machine. In which the rotor speed exactly not equals to synchronous speed, that machine is called asynchronous machine. Synchronous nothing but together. My thoughts syncs with my wife. Right? What is the meaning of that? My thoughts and my wife's thoughts both are similar. Here also, synchronous machine nothing but the rotor speed and the magnetic field speeds are similar together. That's why it is called synchronous machine and it is called asynchronous machine. Sir, in generally, every machine operates in two modes. Yes or no? Every machine operates in two modes. One is called generating mode and other one is called motor mode. Every machine operates in two modes of operation. One is generator and other one is motor. In synchronous generator, what is my rotor speed? Of course, synchronous generator, synchronous motor, whatever it is a synchronous machine, right? So, even though it is synchronous generator, the rotor speed exactly equals to synchronous speed. Even though it is a motor, but this is a synchronous machine, that's why the rotor speed exactly equals to synchronous speed. This motor is called synchronous motor, this motor is called synchronous generator, but in generally, conventionally, we are called this synchronous generator as a alternator. It is called as a alternator. In alternator, the rotor speed exactly equals to synchronous speed. And in synchronous motor, the rotor speed exactly equals to synchronous speed. But in induction generator, what is the rotor speed? And in induction motor, what is my rotor speed? You know, already we discussed, yes or no? Induction generator, the rotor speed not equals to synchronous speed. Of course not equal, but how much, sir? It is a greater than synchronous speed. As usually, in induction motor, the rotor speed not equals to synchronous speed. But how much it is? It is less than synchronous speed. Now you get an idea what is synchronous speed, what is synchronous machine, what is induction machine. Synchronous machine nothing but NR and NS both are same, but in induction motor both are not same. But here, even it is synchronous generator or synchronous motor, the speeds are equal. But in induction generator, it is greater than actual speed or synchronous speed. It is less than actual speed or synchronous speed. This is a brief introduction about what is synchronous machine and what is induction machine. Right? Let's see here. Where we are using alternators. Can you tell me the answer? Yeah, very good answer. Where we are using our alternator? In generally, the alternators are operating in power plants. Very good answer. In which power plants can you tell me? Can you give me an exact answer? Very good. In generally we are using in hydro power plants. Example Srisailam, Nagarjuna Sagar. Still, yeah, Hirakud, whatever it may be, Bakranangal. In where the power is generating by using water force, hydropower plants, in those cases we are using alternators. Of course, in thermal power plants, of course, in nuclear power plants, we are using alternators. Nothing but synchronous generators. Yeah, exactly correct answer, sir. Now can you give me the answer? Where we are using induction generators? Where we are using induction generators? This is a difficult question, sir. Maybe we won't use induction generators. That is not correct. We are using induction generators, but where? Where we are using induction generators are used in wind power plants. Induction generators are used in tidal power plants. Sir, why we are using induction generators in wind and tidal power plants? Why not in hydro, nuclear and thermal power plants? Because the speed of the water is constant in hydropower plant. But the speed of the wind is not constant. The speed of the tides is not constant. But here the speed of the water is constant. The speed of the steam is constant. If the speed is constant, we should use alternators. If the speed is not constant, we have to use induction generators or DC generators. Yeah, this is simply about the synchronous and asynchronous machine. Of course, synchronous motors are not a self-started motors, but three-phase induction motors are self-started motors. We have many differences between them, but this is a introduction, just an overview. After completion of our synchronous machine subject, you have to make a chart. One side induction machine, another side synchronous machine. What are the differences? What are the basic principle differences? What are the constructional differences? What is the difference in EMF equation? What is the difference in torque? What are the differences in application? You should prepare a chart, right? That is very important for examination, competitive examination. Then only you have a grip on every machine. Electrical machine is only single subject. We are distributing into 4 parts for easy understanding. But you should study the electrical machine as a one subject. Then you have get a grip on all the subjects, all the machines. Right? Up to now we saw that synchronous machines are 2 types. One is the nothing but synchronous machine operating in 2 modes. One is the synchronous generator, nothing but alternator, and other machine synchronous motor. First, I will discuss about synchronous generator. After this, I have to give you a clarity about synchronous motor. But before that, if you listen alternators carefully, this is nothing. Everything is reverse, that's it. So listen carefully about these alternators. Listen carefully. First of all, what is alternator? Can you tell me? What is alternator? Before that, we have to discuss about synchronous machine. Synchronous machine having one stator and one rotor. In generally, in synchronous machine stator. In synchronous machine stator, we are using armature winding. And in synchronous machine rotor, we are taking field winding. This is, you have to remember carefully. What about DC machine? Can you tell me? What about DC machine? Let's see. In DC machine, the stator having armature winding or field winding. Yeah, exactly. In DC machine, stator having field winding and rotor having armature winding. 100% correct answer. Sir, in synchronous machine, why the armature winding placed on stator? Or in DC machine, why the armature winding placed on rotor? What are the reasons? I want the reasons, sir. Let's discuss about this one first of all. Let's see. Here I am taking DC machine, and here I am taking synchronous machine. In DC machine, armature winding should be placed on rotor. Otherwise, if armature winding is not on rotor, otherwise there is no commutation. If there is no commutation, there is no conversion from DC to AC and AC to DC. If there is no conversion, that is not a DC machine. So for commutation, we should place the armature winding on rotor. If armature winding placed on stator, there is no commutation action. That's why we must place the armature winding on rotor. This is the reason why the armature winding placed on rotor in DC machine. Very simple. But in synchronous machine, no need of commutation, right? In DC machine, we must need a commutation, but in synchronous machine, no need of commutation. Then tell me, where I have to place the armature winding? If there is no need of commutation, we may place the armature winding on stator or on rotor. If armature winding placed on stator, then field winding should be placed on rotor. If armature winding placed on rotor, then field winding should be placed on stator. Like this. But what I told you now, in synchronous machine, must and should, armature winding should be placed on stator and field winding should be placed on rotor. Why? Because. What is the reason? Let's see here. What is the reason? Synchronous machine. This is the synchronous machine. Armature winding placed on stator and field winding placed on rotor. Armature winding placed on stator and field winding placed on rotor. This is preferable synchronous machine, I said you. Sir, if armature winding placed on rotor and field winding placed on stator, what are the difficulties or what are the disadvantages for this? Or simply in between these two, which is well preferable, which is more advantageous? Right. Let's see. Even it is AC machine or DC machine, whatever the machine, the armature winding must carry the AC supply and the field winding must carry the DC supply. Armature winding must carry the AC supply and field winding must carry the DC supply. That is fixed. right? For example, I said you here, my armature winding placed on rotor. Now I have to give the AC supply to my armature winding. Here, the AC supply giving to the armature winding is very easy because here my armature winding on stator, there is no problem. But here, my armature winding on rotor, I have to give the AC supply, but this is a rotating part. Directly, we won't give the AC supply. We have to give the AC supply through the brushes and split rings, through the brushes and slip rings. So here I am giving three-phase AC supply to my AC motor, through the brushes and split rings or slip rings. Brushes and slip rings. But here we are giving directly to the machine. Sir, of course, you are forgetting that here the field winding is there. We have to give the DC supply to the field winding. Yeah, of course, here DC supply given to the field winding. Of course, this is a rotating part. So we should give the DC supply through the brushes and slip rings. Brushes and slip rings. This is a stationary armature and this is a rotating armature. Stationary armature and rotating armature, two configurations. Now tell me which is more preferable? Which is more preferable? See here, here I want two brushes and two slip rings. But here I want three slip rings and three brushes. If armature winding placed on rotor, I require three slip rings and three brushes, nothing but more than this. Nothing but here cost increases, nothing but here size increases, nothing but here weight increases, size increases, cost increases, weight increases, and maintenance increases. Maintenance increases. Yes or no? Maintenance increases, and very important thing. Can you tell me what is that? Here we have a three brushes. Here we have only two brushes. One more brush is there. Hence the brushes made up of carbon or graphite, high resistive material, which increases the losses. What happens, sir? Increases the losses. This is also very important thing. So why the stationary armature is more preferable, or why the rotating armature is not preferable? If they ask you a question, then you have to give the answer here. Here we require more number of slip rings and more number of brushes, which increases the cost, size, weight, losses and maintenance. That's why we should prefer the stationary armature. And also here the armature winding on stator, if these two are the generators, it is very easy to collect the current. The collection of current is very easy. But here collection of current is difficult in the generators. In the generator, the current generated in the armature only. So here the generated current giving to the load or taking from the armature is easy, nothing but easy collection of current, but here difficult to do collection of current, and here some losses will take place, and here some disturbance is there due to slip rings. So easy collection of current, less number of slip rings and brushes, and here the very important thing, less and easy insulation. Here this is on stator, that's why we can make the insulation easily, but here somewhat difficult. And also here easy cooling also easy here, but here somewhat difficult. Many advantages are there for stationary armature. Many advantages are there. Now, I will give you what are the advantages of stationary armature. You should note down those points. Right? So, I'm giving you what are the advantages of stationary armature. First one, easy collection of current. And second one, easy insulation. And third one, less number of brushes and slip rings. And next one, less cost, less weight, less size, less maintenance, less losses, and more efficiency. Easy collection of current, easy insulation, less number of brushes and slip rings, less cost, weight, size, maintenance and losses, more efficiency. Apart from these, very important, less leakage flux. Less leakage flux. If leakage flux is less, good voltage regulation. Less leakage flux and good voltage regulation, because here the armature winding placed on stator, there is no problem with leakage flux. Otherwise, if armature winding placed on rotor, here some leakage flux is there in the air gap. If armature winding placed on rotor, some leakage flux is there in the air gap, but there is no leakage flux here. If leakage flux is less, less voltage regulation or a good voltage regulation. These are the advantages of stationary armature, which is very important thing. Advantages of stationary armature. Now let's see about synchronous machine. In synchronous machine, the armature winding should be placed on stator and field winding should be placed on rotor. And my armature winding carries the AC supply and my field winding carries the DC supply. That's why this synchronous machine is called double excited machine. This synchronous machine is called double excited machine. This is a double excited machine. This is a overview about synchronous machine again. Right? Thank you.